Let's take a look at this example. In this case, we have given current which goes through resistor R2, we have given resistance R3, and we have given R1, and we have given voltage source. We're supposed to find R2. How am I supposed to approach this problem? You're supposed to realize that my total current is going to go through resistor R1 and is going to split into two currents. So what I'm going to do, I'm going to simply write that my I total is equal I2 plus I3, right? This current plus this current will give me I total. Okay, so next I can write that I total is also equal voltage 1 over R1. Okay, voltage 1, okay, voltage across this resistor over R1. But someone say, but we don't have V1. But we need this equation in order to find this resistance. So someone is going to say, okay, V1. So how I can find V1? V1, okay, is nothing else just voltage source minus I3 times R3. So current times resistance is the voltage. So this voltage is equal this voltage minus voltage across these two resistors, okay? If I'm going to multiply current, which goes through this resistor, by the resistance of this resistor, I'm going to find the voltage across these two resistors. So I have this voltage minus this voltage will give me this voltage. But someone is going to say, but I don't have this current. But right now we're supposed to not worry about it. We're supposed to just keep writing the equations. Now we're supposed to use algebra. So what I would do in this case, I would simply write that I total is equal I total, right? So I'm going to write that this is V1 over R1 is equal I2 plus I3, right? Because we said that I total is equal V1 over R1 and I total is equal I2 plus I3. So I total is equal I total. So this is true. Next, what I'm going to do, I'm going to simply solve this equation for V1. Okay, so what I'm going to do right now, I'm going to multiply both sides of this equation by R1. So I'm going to have R1 times V1 over R1 is equal R1 I2 plus I3. So R1 and R1 will cancel out. And I got V1 is equal R1 times I2 plus I3. We said that V1 is equal this. Okay, so what I'm going to do, I'm going to substitute this V1 by voltage source minus I3 R3, and this is equal, I'm going to distribute this R into the parentheses, so I have R1 I2 plus R1 I3. Okay, so next I'm supposed to bring all terms which contain I3 to one side and everything without I3 I'm going to move to the other side. So because this term is negative, I'm going to bring it to the right side, and this one I'm going to move to the left side. So I have voltage source minus R1 I2 is equal R1 I3 plus I3 R3. Next, I'm supposed to factorize I3 from these two terms. So I have voltage source minus R1 I2 is equal I3, and I have R1 plus R3. Please notice that at this time we have equation only with one unknown, because we know voltage source, we know R1, we know I2, and we know R1 and R3. So we can solve this equation for I3. So in order to find I3, I have to divide both sides of this equation by the content of the parentheses. So I have R1 plus R3. So I have R1 plus R3. So this and this will cancel out. And I got I3 is equal voltage source minus R1 I2 over R1 plus R3. So voltage source is equal 30 volts minus R1, which is equal 3K, times I2, which is equal, this is my current I2, I can say this is my I2, 3.8 milliamps. So I have 3.8 milliamps over, and I have R1, which is equal 3 kilo ohms, plus R3, which is equal 5 kilo ohms. And this is equal, I'm going to use the calculator again, we have 30 minus 3 exponent 3 times 3.8 exponent 3 negative equals, divided by open parenthesis, 3K plus 5K is 8K. 8K. This is equal 2.32 milliamps. 2.32 milliamps. So this is the current which will flow through this resistor. If I know current which goes through the resistor R3 and I know the resistance of that resistor, I can find the voltage across this resistor. Okay, so let's find V3 and realize that V3 is also equal to V2 because these two resistors are connected in parallel. Okay, so V3 is equal I3 times R3. I3 is equal 2.32 milliamps times R3, which is equal 5 kilo ohms. And this is equal 2.32 exponent 3 negative times 5 exponent 3. This is equal 11.6 volts. 11.6 volts. Okay, so this is my V3. In order to find R2, R2 is equal V2 over I2. So we found that V2 is equal 11.6 volts over I2, and I2 is given, this is 3.8 milliamps, so I have 3.8 milliamps. This is equal 11.6 divided by 3.8 exponent 3 negative. This is equal 3.05 kilo ohms. 3.05 kilo ohms, which we can say this is approximately 3 kilo ohms. We found R2 and we can say that the problem is solved.